Hey guys, let's talk about 5-1 monomials. So, what is a monomial? A monomial is an expression that's a number, a variable, or the product of a number and one or more variables. They do not have negative exponents. They do not have fractional exponents. Yes, we will get there. And there's only one term, so you're not going to see any addition or subtraction at the moment. The degree of the monomial is the sum of the exponents of the variables. Alright, so look at number 1 there. It says find the degree of the monomial. Well, the degree is the sum of the exponents of the variables. So I have an exponent of 7 and an exponent of 4. So 7 plus 4 is 11. So the degree is 11. Letter B there. I have A. He's got an exponent of 1, but when they have an exponent of 1, we don't write that. So I have negative 19, A to the first, B to the third. So my degree is 1 plus 3, so 4. Letter C. I have 62, r cubed, s, t squared. Remember there's an exponent of 1 with the s. So I have 3 plus 1 plus 2 for a grand whopping total of 6. So the degree of that guy is 6. Alright, now we have some rules. You're going to need to memorize these rules. That's why I put them in a box. We're going to use them forever. So we have exponent rules, and it says what do we do with a negative exponent? Well, when we have a negative exponent, that's the same thing as moving it to the denominator. So when we move it to the denominator, the exponent becomes positive. And if you have a negative exponent in the denominator and we move it to the numerator, it becomes positive. So anytime you have a negative exponent, it makes it move either to the numerator or denominator. Product of powers. The product of powers, if I have a to the m times a to the n, then that's a to the m plus n. I'm going to add them. Quotient of powers, a to the m divided by a to the n, I'm going to subtract them. Alright, so simplify, it says in number 2, write the expression without parentheses or negative exponents. Alright, well let's just rearrange things, or do it a step at a time, I should say. Negative 2 times a negative 5, that would give me a positive 10. I have a cubed and a to the first, so I have a total of a to the fourth. And I have b to the first and b to the fourth, so I have a total of b to the fifth. So I have 10, a to the fourth, b to the fifth. I added my exponents, kept my base, add my exponents. Alright, look at letter B there. It says s squared divided by s, and s can't be 0 because I don't want to divide by 0, so that's all that means right there. Well, my rule says when I'm dividing, I subtract my exponents. Okay, so s to the 2 minus 10. Well, 2 minus 10 is negative 8. That means I have to move it to the denominator, so I get 1 over s to the 8. Now that's a lot of extra steps. Let's just look and see what happens. Where's the bigger exponent? He's in the denominator. That's where he's going to end up. Okay, so when you're subtracting, instead of doing all the jazz of making it negative and then moving it, if you see, okay, the denominator is bigger, the exponent's bigger in the denominator, so I'm going to subtract my exponent, that's where he's going to end up. You can also think of those guys as s, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These guys are going to cancel, so I'm left with 1 over 8 s's. Alright, so if I have a negative exponent, it makes it move. If I'm multiplying, I keep my base and I add my exponents. If I'm dividing, I keep my base and I subtract my exponents. Next box, again, you're still going to have to memorize these. Power of a power. I have 1 base and 2 exponents. That means I multiply it. Power of a product. I have something inside parentheses and I have 1 exponent. That means everybody gets it. I'm going to share the love. Now, notice this is different, and if there was a plus between them, we would have to FOIL or something like that. There's no addition or subtraction. Therefore, everybody can get the exponent. Power of a quotient. Two things happen. A divided by b to the n, everybody gets it. Or if it's a negative exponent, it flips the fraction and then everybody gets it. All right, here we go. So let's try some. B squared to the 4th. Power to a power says I multiply. So I have b to the 2 times 4, or b to the 8th. Power of a product. Everybody gets the power of 3. Okay, negative 3 to the 3rd, c squared to the 3rd, d to the 5th to the 3rd. So that guy becomes negative 3 times negative 3 times negative 3 is negative 27. C to the 6th. D to the, I'm multiplying, so 15. Letter C, everybody gets a power of 5. Negative 2 to the 5th. A to the 5th. Divided by b squared to the 5th. Negative 2 to the 5th power. If you're not sure about that, remember you've got a calculator. Just be careful because you're taking that negative 2 5 times. Parentheses, negative 2. To get to the exponent, you're going to use the caret button. It's right above the division symbol. To the 5th power, negative 32. A to the 1st to the 5th, 1 times 5 is 5. B squared to the 5th, 2 times 5 is 10, so b to the 10th. If you need to pause it right there and get caught up, that's perfectly fine. Pause your video as you need to and follow along. Alright, letter D. I have a power of a quotient. Now, when he's got a negative exponent, my rule up here said I'm going to flip my fraction. Okay, so this guy is really 3 over x to the positive 4 now. And now everybody's going to get the exponent of 4, so I get 3 to the 4th over x to the 4th. Again, if you don't know 3 to the 4th, 3 power 4, 81 over x to the 4th. All right, number 4. I have the power of a quotient. Everybody's going to get that exponent of 5, and I'm going to put them in parentheses. So negative 3 to the 5th, a to the 5y to the 5th, divided by a to the 6y to the 5th, b to the 4th to the 5th. Negative 3 to the 5th, parentheses, negative 3, power of 5, negative 243. A to the 5y to the 5th. Well, 5y times 5 is 25y. A to the 6y to the 5th is a to the 30y. B to the 20th. All right, now, as you notice, we have an a in both the numerator and the denominator. Okay, so now we're going to use our quotient of powers rule. And it says if I have the same base, I'm going to subtract my exponents. All right, well, as we talked about in number 2b up here, which one's bigger, 30y's or 25y's? 30y's is. So I'm going to subtract them. 25 minus 30 is a negative 5, but we know he's going to be in the denominator, so we can say 30 minus 25. So I have negative 243 divided by a to the 5y, b to the 20th. All right, last thing. Scientific notation. Scientific notation is used to express very large or very small numbers. You should have been doing this in chemistry. You might have seen this in chemistry already. So, in 5A there it says, express each number in scientific notation. We only want one digit in front of a decimal point, and then we're going to do it times the power of 10. So, I only want one digit in front of the decimal place, which means I'm going to move my decimal point 1, 2, 3, 4, 5, 6 places this way. And I'm going to write all the numbers that I have. So I have 4.56 times 10 to the, and I moved it this way 6 places, so it's times 10 to the 6. When you move it to the left, it's a positive exponent. When you move it to the right, you get a negative exponent. 1, 2, 3, 4, 5. So 0.9, I lied to you, 9.2 times 10 to the, and we moved it 5 places, so he's the negative fifth. We can use scientific notation as well, and with our properties of exponents, our rules here to help us out. Alright, so when we do that, I'm going to take the 5, these guys are multiplying, so I'm going to take 5 times 7 and get 35, times 10 to the, now when I'm multiplying, my exponent rule says I add them together. So what's 3 plus 8? It's 11. So I have 35 times 10 to the 11th. Now, I can't leave my answer as 35. I need to move my decimal point over. You have one digit in front of the decimal point. And if I move it to the left, I'm going to increase my exponent to 12. So 3.5 times 10 to the 12th. Okay, letter B. 1.8 times 4 gives me 7.2 times 10 to the negative 4 plus 7. So 7.2 times 10 to the third. All right, pause right there. Make sure you understand all of that stuff and you've got all your notes filled in. And go find your worksheet, and let's do a couple from your worksheet. All right, so your worksheet says 241 at the bottom, it says 5-1 at the top. I'm just going to pick a couple that I know look a little bit tricky, like number 3 looks a little bit tricky. I have 2 exponents, they're both negative, but my rule says when I'm multiplying, I add them. All right, so negative 4 plus the negative 3 gives me a to the negative 7. I can't leave my answer with a negative exponent, so he's going to go to the denominator. So that's 1 over 8 to the 7th. Let's look at like number 8. That 3 only goes to the 2 and the z. So I have negative 5, 2 to the third, z to the third. Careful with your 2's and your z's. So I have negative 5, 2 times 2 times 2 is 8, z cubed. So I get negative 40, z cubed. Let's go down and look at like number 19. Alright, I'm going to reduce these guys as a fraction. So negative 6 divided by 36 gives me a negative 1/6. I have 4 a's on top and 7 a's on the bottom. That means my a is going to be in the denominator, and 7 minus 4 is 3. I have 1 b on top and 2 b's on the bottom, so my b is going to be on the bottom. 2 minus 1 is 1. And I have 8 c's on top and 1 c on the bottom, so my c's are going to be on the top because that's the bigger one. 8 minus 1 is 7. I made my fraction bar a little big, but it's negative 1 c to the 7th over 6 a cubed b. The a cubed and the b have to be in the denominator. Alright, 21 through 24, I think you can handle writing them in scientific notation. Make sure you use all of the numbers. The only other one I want to look at is number 26. All right, when you have scientific notation and you're dividing, you're actually going to divide them in your calculator. So I have 9.6 divided by 1.5. And I get 6.4 times 10 to the, now, what do I do when I'm dividing? I subtract. So I have 7 minus a negative 3. So this guy is going to be 6.4 times 10 to the 10th. All right, so that was monomials.